Alright, hello everyone, welcome to Rasayan Academy. So guys, this video is basically based on question solving. Okay, so I have taken in today's session, I have taken stereochemistry. This is a very important topic for all the competitive examinations for CSIR, for GATE, everything. Alright, so in this video, I have tried to take some questions, and in the description link of this video, I will give you a PDF file also from where you can practice more questions, right? And those questions will be discussed in further videos. All right, so yes, let's begin for today. All right, yes, so the first question is, in the molecule of D-glucose, if we talk about, designate the stereogenic, chirotopic and prochiral centers. Alright, so basically this question is easy as well as a little bit confusing. So if you already know about these terminologies, what is a stereogenic center, what is a chirotopic center, and what is a prochiral center, right? So if you already know about them, then it is going to be very easy and you are going to quickly solve this question. Okay, so let's first discuss what is a stereogenic center. Okay, so first of all, if I take an example like this, right, if I'm taking a very simple molecule, glyceraldehyde for example, and I'm just writing one of the stereoisomer of the aldehyde like this. Now if I talk about this center, this carbon over here, it might be chiral, it might not be chiral, but the question is, if I am exchanging these two groups, the H and the OH, if I am basically exchanging their positions and if I am writing it like this, okay, so is it chemically giving me a new isomer? Alright, so just by theoretically changing the position of the H and the OH, if I am getting a new isomer, then it is the center is going to be a stereogenic center. Alright, why? Because it is generating a new isomer, right? It is generating a new isomer, okay, new stereoisomer basically. Okay, so that is why this is our stereogenic center. So hopefully this is understood by you. Now let's move on to what is chirotopic. So guys, chirotopic is nothing but chiral. Okay, so whenever our carbon center, it can be any other center also, when it is connected to four different groups, then we say it is our chirotopic or chiral center. Alright, what about prochiral? Now this is another very important terminology. What is prochiral? Okay, so based on prochiral, there are a lot of systems which are prochiral. For example, let's talk about our carbonyl group. Okay, so a carbonyl group is one that, you know, it has two faces. We know that a carbonyl group, it is basically a planar molecule, so it has a plane, or basically it has two faces. The nucleophile can attack above the plane as well as the nucleophile can attack below the plane. Okay, so this thing makes two prochiral faces. Now I hope that you have a little idea that what is prochiral. Prochiral is before chirality. It is before chirality, so that if I am, you know, just adding a nucleophile onto the carbonyl group, it is giving me this tetrahedral intermediate, and for example my R and R dash groups are different. Now it makes a chiral carbon. Okay, so prochiral is before chiral, right? So for example, now I am having this molecule, our dichloromethane for example, just like this. So now again this carbon is a prochiral carbon. Okay, or rather if I write Br, you know, just making these two group different and these two protons same, and by replacement of one of the protons, either this or this, it is going to give me a prochiral, it is going to give me a chiral carbon, right? So this carbon right now is a prochiral carbon. Okay, so let's see in this molecule of D-glucose what are stereogenic, chirotopic and prochiral centers. Alright, so first of all I look at an aldehyde over here and I see that is definitely going to be prochiral. Why? Because we have just learned that a aldehyde or a ketone is going to, when it already has different groups, see this aldehyde has one hydrogen and it has one oxygen, and this is the whole R group over here. So definitely it is going to be a prochiral carbon, because it can invite the nucleophile from above or below the plane, and that is going to give us two different enantiomers. Okay, similarly this carbon is also prochiral, because here this OH is there and the R group is there, this whole, and the two hydrogens are there. So if we are replacing one of the hydrogen with Cl or Br or any other group, then this also gives us a chiral center. So basically the 1 and the 6th are our prochiral centers. All right, now let's talk about stereogenic. So what is stereogenic, guys? So देखो, we are having 1, 2, 3 and 4 such carbons, that on which if I replace the group, right? So if I'm just replacing the OH, for example I'm writing H over here and OH like this. So this is my OH, this is OH, and OH over here, this is CH2OH. Now is it giving me a new isomer? Definitely it is. Here both the, this is what, guys, you can just, this is a shortcut of writing glucose, right? 2122, which means that O, this side is our 2 and this side is 1. So this is 2122. Just for remembering the position of the OH group, we can remember it like this, that glucose, D-glucose is 2122. Now this is a new isomer, isn't it? This is 1122. Okay, 1122, and this is our D-mannose, and we can say that glucose and mannose are C2 epimers. So yes, this is our stereogenic center. Why? Because just by replacing the position of H and OH group, we are now able to generate a new stereoisomer. So carbon 2 is stereogenic. What about carbon number 3? Let's replace the H and OH. So this is our CHO, this is OH, H, and on carbon 3 we are replacing this over here like this, OH, H and OH, and a CH2OH over here. So even though, yes, so now just by replacing these two OH and H positions on carbon number 3, again we can see that this is a new isomer, right? So this is also stereogenic. Both of these are stereogenic. Okay, now let's talk about carbon number 4. Alright, writing the same molecule again, just with the positions of OH and H replaced on the 4th carbon. Alright, so guys, yes, again if I check now, am I getting a new isomer? Yes, I am getting a new isomer. Okay, so similarly these are our chiral carbons, and as long as we are having CHO and CHOOH, these are two different groups that we are having. So as long as we are having different groups on the above and below over here, this is definitely going to give us a new isomer if we are changing the position of all of these groups. So all of these 4 chiral centers, so we are having 4 chirotopic centers, as well as how many stereogenic? We are having 4 stereogenic. Okay, okay, just let's just see the chirotopic ones. अभी तक हमने prochiral देखा है और stereogenic देखा है, 2 prochiral centers and 4 stereogenic. Okay, let's now look at the chirotopic also. So what is chirotopic, guys? Chirotopic means chiral. Okay, so this one is chiral, is it? Yes, hydrogen, OH, CHO and all of this R group. Yes, it is chiral. Let's move on to carbon number 3. Is it chiral? Yes, as we can see, it is also chiral, connected to 4 different groups. These are the 4 different groups it is connected to. Yes, so it is chiral. Similarly, let's move on to this one. Is it chiral? Yes, we can see. So again, as long as we are having CHO and CH2OH over here, these are different, then all of these carbons are also going to be chiral. So in the case of D-glucose, there are 4 stereogenic and 4 chirotopic center, but it is not it is not always going to be the case. For example, if I am having this molecule, for example, I am just having this molecule over here, just to give you an example, CH2OH, right? Then this carbon over here would be stereogenic. Definitely it would be stereogenic. But would it be chirotopic? No, it would be achirotopic. Why? Because now it is connected to two similar groups. As you can see over here, these are two similar groups and one OH and H. So it is not necessary that all stereogenic centers are going to be chirotopic. It can be achirotopic also, and this is going to be clear when you solve more and more questions on the same concept. Alright. Now let's talk about the second question. So among the following compounds, which of the following will exist as a meso compound? So again guys, I would suggest you to stop the video. This is an easy one, you can do it by yourself as well. Okay, so what is a meso compound guys? You just have to look for a sigma plane of symmetry. Okay, you just have to look for a sigma plane of symmetry. Now let's see. No, see, just if I draw this molecule like this, then wouldn't it be very easy for you to imagine the sigma plane? It is given Cl is above the plane, so let us just write it above the plane, and this is, both of them are chlorine. Okay, so how to imagine a sigma plane over here? See guys, it's very obvious that because the Cl and the H are different, or basically because these two atoms are different, we cannot make the molecular plane, or basically we cannot consider this plane to be a sigma plane. Alright, the plane in which all of the carbon is there, we cannot consider this as a sigma plane. Why? Because above and below only, see, these are same, these two Cl are same, the CH3 is also same, but over here we are having two different groups. So we can say that there is no sigma plane which is cutting the molecule into half. Alright, and if we look at this way, then also both the Cl and CH3 are different, so there is no sigma plane over here, no sigma plane. Alright, what about if we look at option number 2? So just for your understanding, always when you are when you are seeing a molecule like this, try to consider the cyclobutane in this structure, in this form. It would be very easy to understand. Dekho, the Cl is above the plane, so I've just kept it above the plane. This is methyl above and Cl below. So now can you see a sigma plane over here? Yes, you can definitely see a sigma plane which is going to bisect the molecule into half like this, and it is containing the Cl atom, the H atom, this Cl atom, this methyl atom, and these two carbons. Alright, so very clearly you can see a sigma plane over here in this molecule, and this is going to exist as a meso compound. Alright, so let's talk about the other two as well. So similarly you are going to draw the cyclobutane like this, and this is our CH3 above the plane, this is CH2Cl and CH3 like this. So definitely guys, if you take your time and try to find out the sigma plane, we can see there is no sigma plane in this molecule. So this is optically active as well as this is optically active. Similarly, let's look at option number 4. So in option number 4, this is methyl above the plane, this is methyl below the plane, rest are our hydrogen. So there is no sigma plane in this molecule, but there is definitely a C2 axis, and you can just rotate the molecule like this by 180 degree. Okay, so this methyl is going to change place with this methyl. Okay, so if it is A, it is B, then after 180 degree rotation you are going to get B over here and A over here. Alright, so this does not have a sigma plane, it has a C2 axis, but still that does not make it optically inactive. This type of molecules are called dissymmetric molecules, which are also optically active. Alright, so the answer is option number 2. This is the only one in which we get a sigma plane of symmetry. Alright. Yes, so now let's look at question number 3. So guys, I am just showing you some types of the possible questions which can be asked from stereochemistry, and hopefully you will find the sheet as well, so that more practice questions you are going to do. Alright. So this question is asking, label the following molecules as a pair of homomers, diastereomers or enantiomers. Okay. So first of all, when you look at this type of a question, what is the relationship that comes to your mind? Homomers are those which are identical. So definitely if they are identical, they are going to be superimposable. Yes or no? I hope this is very clear to you. If they are identical, they are going to be superimposable. If they are enantiomers, they are going to be mirror images. Mirror images which are non-superimposable. Then the diastereomers are the last one, which don't have any relationship, basically no mirror image relationship, as well as they are not even identical. Okay, and when is the condition to see diastereomers? That is what we are going to check out in this question. Okay, so let me just make some space. Yeah, so look at option number A. Do you find any relationship between these two molecules? Yes, this is our first molecule and this is the second molecule. Now you would be very much tempted to put a sigma plane over here, and then you would be very much tempted to call it a enantiomer. Yes, you might feel like that this Cl is getting reflected over here, this F is also getting reflected, both of them are above the plane over here, the symmetry is the same, but you would be wrong, because here we are having a methyl group over here. Okay, so basically what we have to do is we have to clearly see that here the methyl is kept on the top. So if I now rotate this molecule like this, and if I write it like this, okay, so I am just rotating this molecule from this axis like this. I am rotating this molecule by 180 degree, putting the methyl on top. The hydrogen is going to come over here, as well as the position of the fluorine and chlorine is also going to change. The fluorine, which was above the plane over here, is going to go below the plane. Similarly, the Cl, which was below, comes above. Alright, so this is going to be this is what we are going to have. Alright, we have just rotated the molecule. Now if I turn the molecule like this, okay, so now if I turn the molecule and if I see, the fluorine again comes up and the chlorine goes below like this, then, alright, just a second guys, rather what I would suggest you is a very simple thing. It's all about imagination in stereochemistry. Rather, I would just tell you to rotate the molecule like this. Okay, not going for such a long stuff. Rotate the molecule like this, bring the Me on top and bring the hydrogen over here. What would happen? The fluorine will be right over here. We are not just touching fluorine and chlorine, let them be over here only, and we are just rotating the molecule like this. Me is going to stand up, hydrogen is going to come over here, and the Cl and Fe are not going to change their position. So now if you look at and compare these two molecules, they are what? They are identical. Okay, or basically they are homomers. Okay, so this was a simple way of finding out the relationship. Okay, let's now move on to option number B. Now what do you see guys? What can you see when you are looking at these two molecules? This Cl is above, this Cl is below, rest of them are hydrogens. Similarly, this Cl is below and it is above. Alright, so what can you do in such conditions? If I try to rotate this molecule, basically, okay, so if I try to rotate this molecule from this axis, what am I going to get? Let's see. Okay, so this is my A and this is my B. So even if I rotate the molecule guys, the Cl which was A is going to come below and the Cl which was B is going to come on top. So even after rotation I am getting the same thing. Okay, and this is something different. So if I now turn the molecule from this axis, if I am now rotating the molecule perpendicular to the axis like this, what am I going to get? This Cl which was B is going to come over here. This is my ClB and this is my ClA. Okay, so now I think it is clear to you that if I put a mirror over here, this Cl is above and it is mirror image of this one. Just now look at the relationship between this and this. Okay, yes, so now look at the relationship. This Cl is above the plane, it is also above the plane. this is below the plane, this is also below the plane. So now we can say both of these are enantiomers. Why? Because we have even tried to superimpose them, but that was not possible. So we can say it is our enantiomers. All right. Okay. Now let's try out option number C. Okay, so guys, when we are having a chiral carbon in the molecule, this is our OH, H and Me. So basically we are having a chiral carbon in the molecule, even if this side, this side is what? It is our trans over here, as well as this is also, as we can see, is trans. Alright, so even if both of them are trans, what is the stereochemistry around this carbon? Okay, so this is basically just the, alright, so if I am just rotating this molecule from this axis, if you see, if I am rotating this molecule from the axis, you will be able to see the hydrogen comes over here, methyl goes above, and this hydrogen goes over here, this carbon is going to come over here, but then definitely the methyl is also going to go up, OH comes above and H goes below. So now these are both superimposable molecule, guys. These are both homomers. Okay, so the connection between these two is also homomer. All right, and yes, what else can I do? If I ask you, if I just keep the chiral conformation the same, this is our H, H, M, E, and this is my OH, H and Me, and if I just take the cis molecule over here rather than the trans, I'm just trying to make it so that you are able to identify what is the relationship between these two molecules. So now if I ask you the relationship between these two molecules, then they are going to be diastereomers of each other. Why? Because here it is basically E, if not trans, we can say it is E, and here it is Z. Alright, so because of that, these two are diastereomers of each other. Alright, okay guys, so hopefully this was clear, and definitely you are going to have much more practice questions. And guys, let me very quickly tell you that what are the courses for June 2020 that we have planned on Unacademy. Alright, so before moving onward, let me just tell you, in the links that I'm going to paste in the description of this video is going to be for the file that is going to have practice question. Around 10 practice questions there are going to be, and we are going to discuss them in further videos. Alright, and also I would give you the link to my free special class which I had taken on stereochemistry itself, so that you can visit more examples. We have practiced a lot of questions in that video as well. Alright, so this is what I'm going to put in the link below. You can access that. And also for the CSIR preparation, for the CSIR NET preparation, June 2020, we had already started our batch courses from January, and I was taking organic chemistry in there, focused more on organic chemistry, and these two are the courses where I had completely done the syllabus is completed for the organic chemistry, and now we are starting the revision. So this course has started from April 5th, right? And this is the ultimate 60 days crash course for chemical sciences, in which we are going to revise everything that we have studied from January to March. Okay, so this is the complete revision crash course, and definitely we are practicing question. So this is the course that has started from April. This is another course, and this is another course. based on coordination reaction and organometallic chemistry, and this is completely based on previous year questions. Starting from 2011 to 2019, we are going to discuss all of the previous year questions starting from May 14th. Alright, so this was about the course on Unacademy. So if you want to join up on Plus, you can definitely use this code for a 10% discount. Okay, Plus is a paid platform, guys, and definitely all of these are free video courses. Okay, these are if you visit the Unacademy Live CSIR UGC NET channel, on this channel I am regularly taking free live classes, and this is the schedule of the for the month of April, right? This is the schedule for the month of April, and I'll be making you solve a lot of questions if you come up on the Unacademy Live. Okay, and this is the schedule for the special classes for the month of April, and this is also all free. Okay, so many classes are free. Till now we have done aromaticity, stereoisomerisms, and we will be soon doing reaction mechanisms on 11th of April. Alright guys, so this was it. Thank you so much for coming up and listening out. So if you like the video, please give it a thumbs up, and please also share my profile if you think it is the content is good, and also subscribe for more such videos. Thank you so much, and I'll see you very soon.